So we'll start.
Sorry, just move my phone.
So we're at week 9, so it means 10, 11, and you're done. So it's we're close to the end. So last lecture we did confirmatory factor analysis. So last lecture we covered confirmatory factor analysis via structural equation models, and today it will be a rather short lecture. We'll look at mediation, and I'll also have an exercise for you in petto to sort of retrain some of the things you did, which you might have struggled with in some of the first assignments. So today we'll talk about mediation. We've done mediation before, and we'll do it via structural equation models. And then next week we have multi-level. And again, I won't be able to make you a multi-level expert in just 2 lectures, but I'll give you the overview, and I'll show you how to build some basic models, which you can then use for your practicals or your, and which you'll also do in the assignment. So for the assignment after today, you should be able to complete mediation via SEM, and we're getting close to the end. If you've been following along with the second assignment, after this, there's just multi-level to be done, and then so there's no reason why you couldn't be working on your assignment 2 at this stage. Now, let's talk a little about knitting hell, which some of you might have experienced. So, perhaps they're in the back, yeah. So, some of you experienced knitting problems, and so that's the discrepancy between it just running fine when you press the buttons, and then when you knit the document, it doesn't go very well. And so I think what has happened is that you the issues you have are not necessarily to do with the knitting program or itself, it's your code where there are issues. So as I've explained also in week 1, R is forgetful. So if you don't load things within a chunk, so if you don't load a package or your data set or anything like that in that chunk between the 3 ticks, then it's not there. And so you might get very different things where it will run if you're pressing the buttons, because you've either loaded a package via tick, or you've installed the data set, or if you've had it before. But especially if you have a very long script, by the end, R will no longer remember that you've loaded the data set in the beginning, and it will do so in RStudio because then it's stored in your environment. When you're knitting the document, it won't. And this is something which I've mentioned also in the very first thing, and if you've done the exercises, something you might have come across when you're knitting the documents. So likely it's not knitr causing the problems. There are some very specific things with knitrs which you might have seen, like sometimes it will overrun your code, like it won't stay between the fences as you've seen on some of my slides. But those are minor things. But not getting into knit likely is not an issue with knitr itself, it's with how you build your code. So you're either referring to data files which no longer exist, packages which no longer exist, all sorts of other things. So likely it's those type of issues are causing your problems when you're trying to put it together. So where you go, oh, my data set is being corrupted, or it no longer runs and I get 27 different errors. It's because you didn't tell it what to do within the chunks. And so that's the discrepancy between running it via the play button, which you've done most of the time in class, versus knitting the actual document. And if you've taken part in the exercises, I encourage you to knit the documents and to build those documents. I've posted some tips in the discussion board for common problems with knitr. I might not be able to resolve all your specific problems because there's no way I can reconstruct if you either ticked a box or if you actually loaded your data set and then renamed it and then intermediately saved it into your workspace. I can't reconstruct what you've done in that case. But when it comes to your assignment, I'll review your R Markdown document as well as all the other files you submitted. So likely it's not anything to do, so don't blame knitr too much. It's not necessarily something to do with knitr per se. It's with how you set up your code and referring to objects which no longer exist. And it seems that some people have no issues doing that. So also I've noticed that some people are knitting a bunch of things. So within the 3 things in the beginning, you have, it says output, and it can make a PDF file, a Word file, an HTML file. It usually doesn't like doing multiple formats at once. So several people might have removed, and as you've seen from the R Markdown when you built an example file, will only generate an HTML file and not from the same file generate an HTML file and a PDF file and a Word file. Because sometimes they have very specific issues. So the PDF thing needs to know some things in terms of how signs are coded, and that leads to problems. So if you have problems, try reducing the output so it only produces an HTML document rather than an HTML document, a Word file, a PDF file. And sometimes that might take away some of the issues you've had. And so if you load a new blank script, then it will. So if you do build one from a template, it will say this will be an HTML document, this will be a PDF document. So part of the issue might be that you've tried to knit too many documents at once, trying for it to make a Word document and a PDF and an HTML from the same time. And then at some point, if you didn't put in the data sets within the chunks or the package within the chunks, it will have forgotten because it's knitting the Word document as well as knitting the HTML as well as knitting the PDF. Yeah. So if you get into problems, as some of you might have done, first knit an HTML and just save it as PDF. For this assignment, it's fine. You can get beautiful PDFs out of it as well, but for this one, it's fine if you just knit the HTML. Okay. So most likely what happened, I think for some of these, you loaded package or data set in RStudio, but you didn't load it within your chunk, and you're referring to an object or package which no longer exists and which knit R, when it's trying to knit those things, doesn't have access to. And if you look through it will print error messages and it will say which chunk is causing the problem. So if you're trying to knit a thing, R Markdown will say which chunk is causing the problem. And so that it will also print some type of error message. Usually it's like something not found, something doesn't exist, don't know how to handle this. And you can use that to reconstruct what's going wrong with that particular chunk. And most of the time it's something like this object attraction combined, I cannot find it, or I don't know how to handle this command. So some of the time you can reconstruct what's going wrong within that chunk by looking at the errors it prints. Yeah. So I know it's a hassle to go through all those errors, especially if you have lots of them, but that's the way code debugging works, and that's also what you'll have to do for a new build. In the second semester, when you build experiments from scripts, you'll be faced with error messages, and you're going to have to correct those, and that's part of the intricacies of coding. So it also means that occasionally you'll have to reload the data. So if you have the data in chunk 1 and you're now at chunk 10, it will no longer remember that you've loaded that data. So you will have to reload it from. You will have to again use the haven command or the require command to load the package or the chunk, load the package or the dataset within that bit. Yeah. So those are the most common things there. So R is forgetful, and a couple of places down the line, it will no longer recognize which packages are loaded or which datasets are loaded. It will do so in RStudio because there you have a working environment and it's accessing the memory. But when it's knitting something, it's basically sending everything to the memory really quickly and trying to make this HTML, and nothing is stored in your memory for a very long time in order to do the operations. Yeah. So why don't I then debug your code? Well, that's sort of your job, in the sense that part of this exercise is you working through and finding out where things go wrong and finding out where the issues lie. So one of the most time-consuming and very hardest things to do is actually to work through people's code and find out where they've gone wrong, especially if you use different extensions or different commas or different setups. So don't, just to sort of moderate your expectations, you won't be able to get from me like, why didn't this work in this particular instance, because I might not be able to reconstruct it, because it could be something you loaded, something you ticked. There could be many different reasons why it wouldn't run. Yeah. So what I can do is, and I've actually put on discussion boards pointers as to how to debug, pointers as to what the common issues are when you're knitting the document, and it's your job actually to study the codes which niche R gives you where things go wrong and try to interpret why it won't do what it's supposed to do. Yeah. And you have tips to work from on Blackboard's in the discussion board. I've posted some tips. Also, in earlier section, before all this happened, I had some bits in there. So if it doesn't work with the large document and for some reason it's Armageddon and you start panicking, just knit lots of smaller documents and combine them together via PDF combiner. So you can get smaller things to work perhaps, and then you have lots of really tiny scripts doing bits and then combine them together. So for this assignment, this will also work. It's not as clean. The formatting will be lost and you might lose 1 or 2 marks perhaps on formatting, but at least you'll be able to get the entire document together. Yeah. Any questions at this stage or things? So I think it was quite bimodal, so some people had no issues whatsoever in, I think, knitting the documents and getting the final document to convert it into an HTML, and some people really struggled and spent hours and hours, and I know it's very frustrating to do that, but it's, yeah, it's just a matter of practice also, yeah? So again, I'll reiterate, try to do the exercises. If you submit any type of exercise, I'll just give you the solution for you to check against. So they're there for you to practice, and they're there for you to also practice the knitting process. So if you haven't done any exercises, just make the exercises. Yeah, and I think there will be quite a strong correspondence between people doing the exercises and them doing well in the assignments, because the things for the people who have done the exercises, I think the correspondence between the exercises and what you actually do in the assignments is quite high. So I think it should work. So lessons to be learned: practice makes perfect. Attempt the exercises. Do not leave things until the very last moments. Plan for the worst. So that means making multiple backups, testing multiple systems. Do that early on. And yeah, pretty hard lessons. So also, this is magic. Everything is it's a sign. Okay, so so towards next year, I'll reiterate early on because some of you said you didn't recall knitting it, but you have done so in the first class actually, and perhaps also when you're doing the exercise in class, now and then press the knit button to make a document out of it. So I give you in-class exercises. Most of you just tested by the run button, which is fine, but you can also knit those exercises. And again, from week 1, if you submit the exercises and knit those, you'll quickly learn what the problems are and where you encounter problems. Yeah, but I'll make some pointers towards next year so this doesn't happen again. So the next generation will learn. Okay, so today we're going to talk a little bit about mediation. So this is not a very readable graph, but it's a very common way to structure causal models, as you recall, and we're quite interested in trying to find out pathways where something is in the middle. So you might be able to see this on your actual screens, but not on this screen, and if not, I'll put it in a larger graph. But this is just an example from a paper where they tried to study health behaviors, and they first have at the causal chain the region people are living in, and that predicts all sorts of things like dietary intake, dietary quality, how often people move, and ultimately death. So they're saying these things in the middle predict the likelihood of mortality, and so they build a causal chain in this way. And so many of the models we have in psychology or in epidemiology or in clinical psychology or in any type of those disciplines, we're interested in trying to study the mediators, and we're trying to study the mechanisms in between. Yeah. Why is this useful again? No? None of you have actually done this, but most often theories are also formulated in terms of mechanisms. So for example, a theory of planned behavior or something, or another theory says something will be in the middle and will be the causal mechanism explaining the path between, for example, attitudes and behavior. Yeah. So something in the middle like cognition or emotions or something else would explain the link between those two things. So it's useful to actually formally test theories in that way, because you could make an alternative theory where there's nothing in the middle or where there's a different causal mechanism, and that's why you need to know about structural equation models and also about mediation models. Yeah. Any questions so far about mediation models or? So back to our hypothetical example. So I think it was week 6. with a hypothetical data set. If you did the exercise, you might recall that was some data from Pierce Cornelissen looking at body image, and where you were able to build your own mediation model for body image, looking at a doors task and looking at people's perception of their body. So we already did some of the mediations, and you remember what we used? There were separate methods to do this. There were actually three methods. Does anybody remember what we used? One method. How were you testing mediation? I think I hear whispering of Sobel test. Yeah, so Sobel Z test was one thing. So you remember one of the things was the three-step approach by Barron and Kenny, and then the formal test was the Sobel Z test. Then we saw some variants based on the Sobel Z test. We saw how we could bootstrap it, so how we could bootstrap that A/B type of product. And we also saw some really advanced thing with Acme and AD, looking at the Imai and Tingley method. Good. So we return to the example which we had, which was a hypothetical example about grades, happiness, and the proposed mediator being self-esteem, which we did in class in week 6.
Sorry.
So that's a very long string, but that's how we're reading the data. It's exactly the same as we did in the first thing. And now in Lavan's notation, we can also write mediation models. So last week we saw in Lavan that we could write factors, and that we could write conformatory factor models. And now we write a mediation model. So what we do is we now specify the direct effect, which is C, the mediator, and then the mediation effect. Then we can indirect effect, as you might recall from the Sobel Z test, is nothing more than a product between A and B. So it's the A-B type of test. And the total effect is nothing more C plus the AIB effect. So the direct effect of this plus the indirect effect. Yeah. Does that make sense? If you draw it back with those arrows, we have an indirect and a direct effect, which leads to the total effect. So here we've just specified out all those equations which we had in that diagram from week 6. Yeah. And so you don't need to hashtag in between, but they're there to annotate what is going on, and you should recall that this sort of defines the functions. So we explicitly define those parameters C, A, B, and then we want to find out A, B, and the total effect. Yeah. So massive output, as you might recall from last time. So we fit the mediation model sum. We can ask for bootstrap standard errors, as we did before with the mediation where we bootstrapped it. I'm not sure if you remember, but we bootstrapped some of those paths. And then we'll print a massive output, as we saw last time from confirmatory factor analysis. And I'll just have will overflow. So I'll just open the text file so you can have a look. What I specified here also is that we want the standardized effects, so betas, so everything will be printed as beta, and we can ask for fit measures like AIC, BEC, which you also recall from last week, root mean square error, RMCA, all those other things will also be printed. And if you wanted to, you can also ask it to print R squares and like all sorts of other things. So you can have a further look at commands for summary. But let's have a look. So here we go. So massive output. We had 100 observations. We're estimating via maximum likelihood. And then we have these fit images, which you recall from last week. So they're quite good. So because they're 1. So that's because we also made a model which is sort of saturated in the sense there's lots of arrows going on. So it means it will be quite a good model. We can't interpret these AIC, BEC things unless we compare them to a different model, as you recall. So that's what we did last week with factor analysis. So we built a 1-factor model and a 3-factor model. And so in a similar way, you could build different models and then compare them via AAC, BEC. No worries. And then compare them that way. And then you can have the RMCA, which you had last week as well. But what we care about most is those parameter estimates. And so it's printed those regressions. It's printed the p-values, but these are now betas. So there you can interpret them as betas from regression. Yeah. And so that path between that direct path between x and y is no longer significant. As you remember from the Sobel Z thing, that's what we want. So we first had a significant relationship between x and y, and it is no longer significant when we account for the mediator. It will estimate the remaining variances. So those were the arrows pointing from, which you remember pointing in the confirmatory factor analysis model from last week. Either the arrows pointing or those double-headed arrows. But we care most about this A-B type of path because that's, if you remember that arrow type of diagram, it's those type paths multiplied, and if that's significantly different from 0, then we have evidence for mediation. And that's also what the Sobel test is doing. But here we bootstrapped it. So that's quite a sizable beta, significant with this type of Z value and this type of things. And it will, if you want, you can also then further ask for you to print 95% confidence intervals and all sorts of other things via further commands. That's sort of doing the same type of mediation which we did last time, but in a different way via structural equations. So why is this useful? Well, the nice thing about the structural equation models is because we can now compare them to different type of models because we have AIC, BEC, and they're all set in one type of framework. So we'll come to some examples later, but you might be at some stage willing to combine factor analysis and mediation models, and you'll be able to do that with just this type of single model building package. Any questions? It's quite dry, I know, but it is what it is. Yeah. So, how does that compare to the other methods? You can't see the sims dropping off there, but that's the ACME or AD method which we used last time. And again, also, so we had 0.356. We also have 0.356 here, and we also have a significant mediation in that ACME model and AD model from last time, and we are able to replicate the same findings with the Lavant package as with the mediation package, which is good. Yeah. So what are the benefits? You can compare it to other pre-specified models. So you can have a model. So these other packages which I've showed you earlier cannot do very complex mediations where you have 2 or 3 potential mediators or 4. So that becomes quickly quite difficult. So you can then compare, for example, does a model with 2 mediators do better than one with just 1 mediator? Does one, if I added more things in the chain, so if, does that model fit better than one with just one thing in the middle in the chain? Yeah. So you can then compare all those different models in terms of fit in the issue. So you can draw out all your theoretical models and compare them and say the evidence for this is higher than for that, evidence for that is higher than for this. And so that can be quite useful, especially if you have a pre-specified model, for example, the theory of planned behavior or some other type of model where you have predictions as to how many mediators there should be and what their contribution should be. So we can use model fit statistics to compare models, and it's also easier if we have multiple mediators and even latent constructs. So suppose that you want to capture your questionnaire, you would do a factor analysis. In the other scenario, you would do a factor analysis first and then use the factor scores, for example, in the mediation. Here you can do everything in the same model. So you can build a confirmatory factor analysis model and then have that predict something else. And I'll give you an example later on. Again, it's quite data hungry, so you need quite a large data set in order to do this, but it can do all sorts of nifty things. So how does this compare to a model with just direct effects? So we can just specify a model with just direct effects, which would be nothing more than a regression with just C and B. So it's just Now it's just a regression with the independent variable and the mediator as both predictors for our outcome variable in that example. Does everybody understand that? So it's just a very basic model. Again, it will print all the output, massive output. And I'll try and show you what happens. So that's the one from before, and that's the direct one. And here you can actually see that the direct model does equally as well or slightly better for some of the things. So I'm not sure if you're able to see, but you can compare the AIC and BEC. So this is the model with the mediation, which has 5 parameters. This one has 3 parameters. And these are fit indices, and lower is better. So in this case, perhaps it's more parsimonious to say that they're just direct relationships than there is complex things. But sometimes you don't want to do that. You just want to prove your theory or validate your theory, and you wouldn't test against all sorts of other things. Sometimes it's useful to test against a model which is direct effects or some type of null model. Does that make sense? So you can use those fit indices to compare evidence for one model versus the other one. And so in this case, it's around 4 units difference. So it's not like if you had 10 or something, then that would be a very big difference. Yeah.
So what's the difference between like a mediator and a covariate? So that one facilitates it, one just an effect?
So a mediator is always a causal chain type of scenario, and a covariate is where you try to partial out something. You want to find out what is predicting something while controlling for something else. But in a mediating scenario, you're really saying that the path that this effect is explained via this mediator. So it's slightly different. Does that make sense? So
yeah.
one is partialing out the effect. The other one is saying there's a causal linkage between the x variable, the mediator, and the y variable. And so the reason x predicts y is because of this causal link in between, which is the mediating variable. And the other one, we're just interested in controlling for things. So we know, for example, that BMI would be confounded, for example, by age, so that older people are heavier, for example, and we want to control for that fact, so that's why we use a covariate. If you believe that age causes BMI, then you draw a mediation type of scenario. It depends on your question of interest. Yeah. So we can compare those different type of scenarios. Okay. So it's quite easy to fool yourself with structural equation models. I'm going to give you some things like just in this book, they list no less than 50 ways in which you can fool yourself into thinking you've got a good model or thinking that something works. And I'll just run through some of the highlights of common issues. Sample size, I've reiterated, you need a very large sample size. So some people say 200, some people say even higher, like 250 people. Sometimes it depends on what you define as a unit. So if you have multiple measurements within the same individual, so if you're doing a reaction time test and everybody's doing every single trial, then that could count as a unit of measurement. Then actually you have lots of data that way, because multi-level models and structural equation models are quite related, so you can convert one into the other. And you can have lots of data at the lower level, so you might have lots of button presses from reaction times, and you can then make your model based that way. And so, but usually you need large data sets, so it's not useful attempting it with like just 15 or 20. So many of the if you're doing psychophysics experiments with just very few cases, or you're working with a group of, let's say, disabled children or like a very specific populations, likely you will not have the power to build these type of models. There might be cases, for example, if you're developing a questionnaire or comparing patient groups, that you might need structural equation modeling and that you do have large enough samples to do this. So a simple model, you can also think of them as a regression model. So that model that we just saw with the mediation, that already has 5 parameters to estimate. And you remember from regression, you would like to have 10 to 15 cases per parameter to estimate. That was a very basic model. We'll show some more complex models in that further on, but sometimes you need quite a lot of data, especially if you have a complex model. So suppose that you say there's going to be 3 mediators or 4 mediators. That's a lot of arrows that you're drawing, and every arrow needs cases to estimate the relationship. Poor data, making something of nothing. If there are no baseline correlations, so if nothing is happening in your data, then structural equation modeling is not something magic which will suddenly make relationships appear. So if you measured something really poorly, so if there was lots of noise when you were conducting your experiment, or some of the questionnaires were taking a very different setting where it's very hot or very cold and it affected people's scores, then structural equation modeling is not some type of magic will suddenly give you really clean factors or really clean relationships or really clean data. So you should always look at the baseline correlations in your data set. If there's not much going on there, then we can't make something out of nothing. So then it's probably lost and you need to start over, or there's nothing there. Yeah. So SEM won't help in that case. So naming a latent variable also doesn't mean it exists. So it's quite intuitive to start drawing these ellipses and trying to say things, oh, this is verbal intelligence, and this is some different type of intelligence, and this is something else. But that's what we impose on the data. So it's always good to bear in mind that just because you label something as a latent construct and say this is the hidden factor of empathy or something, doesn't necessarily mean it exists in reality. It's because you built your theoretical model that way. And sometimes people get quite set in their ways and thinking it must be this way because there must be this type of factor. There must be a general factor of personality because look, I've drawn this big circle with all the arrows going through it, and that's a very good fitting model, so it must be real. It might not have to be real. It's just you draw it that way, and it's all correlations. Yeah. And again, if you want to establish, so it's also people speak. I've also been speaking in terms of causal relationships. But bear in mind, if you really want to establish causality, you need to do experiments. So you need to experimentally manipulate because ultimately we're dealing with correlations. Everything is a correlation. Yeah. How to fool yourself with SEM? The saga continues. Ignoring warnings. So sometimes Lavan and some other things will print warnings. Sometimes they're just harmless error messages. They're like we've noticed that this is an older command and you're using this command. Those are the type of things you can ignore. But sometimes it's quite serious, like this variance is not fitting well, so it's not a positive definite or something you will get as a message. That means probably there's other solutions to your structural equation problem. I mean, there might be more than one solution. It might be, for example, that you have some very highly correlated variables which you could take together and then use further on. So sometimes if variables really highly overlap, then when you're trying to solve these equations, it doesn't really know whether I should pick A or B or what the coefficient should be for A or B. If they're the same type of thing, it's become very hard to solve it via iterations because that's basically what it does. So some of them are meaningful, and sometimes they're quite useful because they warn you that you're building some nonsensical model. So for example, you might have accidentally put in a loop, so something that goes back to the beginning, and you can't have loops in structural equation models, and then it will give you some sort of errors. So be aware when you're building structural equation models of the type of warnings it will give you. Ignoring practical significance, so you can build a model that fits the data very closely, so that does very well, and that has all the most beautiful TLIs and RMSEAs and CFIs, but it still only explains 1 or 2% of variance. It's a close fit to the data, but it has no practical or biological significance. You're explaining a trivial amount of variance. It might beautifully fit your data model, but not be actually very useful for people to use, for example, when diagnosing or when you're actually going out to plan intervention or some sort, because it might have statistical significance and you might have a very close fit, but it doesn't mean it will change people's lives, for example, when you're doing a clinical intervention or a practical intervention. Yeah. So statistical significance is not the same as biological significance or clinical significance. The bars tend to be higher for that. Yeah. So those were the the highlight points of so you should always be quite skeptical. Also, when you see papers with structural equation models, so something might be a very good model on paper, but it doesn't necessarily mean it does a whole lot of explanation in the real world. Now, before we'll break slightly early, and then it's close to 45 minutes in. I'll show you another couple of ways in which you can get nice little diagrams, which you might use in your papers, for example, from based on Lavaan. So you've written the equation for the structural equation model, and then you can use a package called Lavaan plot to make the diagram which corresponds to your model. So that's quite handy. So you write out the equations, and then you build this. So this has a model that we feed into it, so you don't have to specify anything else. If you define the model in Lavaan language, it will know. This is just saying we want a box rather than elliptical, so you can pick all sorts of shapes. You can have stars, circles, all sorts of other things. This is which type of font you want. If you want Verdana or something, you can pick something else, but you can pick whatever the journal wants it to be. And then you can say which type of color you want for the arrows, for example, and I went with gray arrows. But this might not be what we want because it's going top down. It's a mediation model, but we might want it like we're used to, like going from left to right. It took me some time to figure out how to do that. But this is the solution. So what I did here is I also generated labels. So now it says independent, mediator, and dependent. Yeah. So I've made a list. I've made labels, which is a list, and I said X is independent, M is mediator, Y is dependent. And these bits are just the same, except for that now I say the direction of the graph is left to right, so the rank direction is left to right, and I tell it that it needs to use the labels which we've just defined above, and then it will use use a box and add Helvetica, and then we'll make it gray. So you can draw your theoretical model in a way. Once you've written the equation, it's not that much work. Otherwise, you would have to waste your time in PowerPoints or waste your time in something else to really draw out all those arrows. But once you've defined your model as a structural equation model in Lavaan, you can get a relatively nice looking graph from it. This one doesn't have, but that's more complex. If you wanted to add the numbers to it, you can do that as well, but you have to read more on how to add the coefficients to those arrows. The way to do it quite easily is to do it via subplot. Again, this won't be readable because it's not a very good beamer and it's printed too small, but you can hopefully see it on your Blackboard graph, and when you export it, it will also be quite viewable. So here the labels are in a different order because subplot uses a different order, and so if you would use the previous labels, then it would label them wrongly. It has to do with which ones come first, like M, X, Y, or whether it goes counterclockwise or clockwise. Don't worry too much about it, but just you have to specify the order of the labels. So we needed to reorganize. Use the command subpaths, and then again the Lavaan object that you've just made. STD is standardized, so it's just you won't be able to see on this one, but it prints the standardized coefficients on the arrows now, on the green arrows. You can say how big the label should be, so that's just 0.5. It's way too small for this, but if you print it on a computer screen, it will look okay. Spring, that's the layout, so it's just it uses. So this angle is determined by the strength of the relationships. So it will, if it's like a proper mediation, it will build a triangle. So that's what we might want. Well, what we want as labels is the values from the standardized coefficients. So that's what we are using to plot the intercepts, and then the style. It's a reticular action model, which is called RAM, which is just the layout again. Because there's many different ways you could build a tree model. You can build all sorts of other models. And you can look at style to see what other options you have for layouts and for all sorts of other things. And the node labels, they're corresponding to what we just defined. You won't be able to see, but this is independent, mediator, dependent. We can see our strong green line this way. It's very faint, but that's a line going, and I can make it clearer. It's very, very faint. But here I've made that line more clear, so it's because it's 0.3, and so in the default settings it will sort of print. So this will be brighter green. The stronger the relationship, the more brighter green. And also when you print it in grayscale, it should look quite nice because we'll adjust it. And here I went for the literal, which you remember also from CFA. So now, rather than those double-headed arrows, we have the single-headed arrows with the remaining variants. And I've reordered it so it says independent, mediator, dependent. So that's, again, trust me, it looks nice on the computer screen, but not as nice on the projector. But this is if you need to make like a graph for a mediation based on a structure equation model. I think perhaps this is a good time to break somewhere. In the second part, I know it's quite a lot of listening, but the second part you'll do some of the exercise, and then so 10 minutes or 5 minutes or 10 minutes. What do you need? It is quite early still, so.
Yeah. Oh, go on, Jen. I'd love a filter with skimmed milk.
So
Yeah,
5 to roughly.
Which one?
Yeah, don't trust that clock. That clock is not correct.
Latte. Mocha. Anyone want a skinny drip? Espresso. Anyone else? Nothing. Anyone? Ollie, do you want anything? Thomas, do you want anything?
No, I'm fine, thank you. Pumpkin spice latte now.